I admire the paint manufacturing, of course, because it's always fascinating to see finally how such a paint is manufactured. And here, if you see these nice colors, you see the with the light, yeah, it is fantastic. But however, we have to deal with a serious issue, that is that are the VOC emissions, because they have, as you heard, a direct hazardous impact. For example, if you think on formaldehyde or toluene and other materials, or of course, they contribute a lot to this summer smog of our ozone. So that's the reason we have to think on the requirements when we manufacture coating mixtures, varnishes, inks, and adhesives. So today we will deal with all of that manufacturing processes, so including the adhesives too. Important is the definition, because maybe you think you are under the scope for the manufacturing of paints, but maybe you are not. But that is really depending on the definition. So the definition is always important. So you see, it is the manufacture of the final product, and of course of intermediates, when they are carried out at the same site. So the intermediates are maybe, if only a part of the mixture is manufactured, then that we have to include, but together it must be done on the same site with the final product. Important is, it is a mixing process. It's a mixing of the pigments and so on, resins with organic solvents. And it includes the dispersion and the pre-dispersion activities. So you have in a manufacturing process, those, of course, who work every day with it, they know already, of course, it's nothing new for you, but we have other people here, participants, maybe you are not so familiar with the paint manufacturing. So I will explain some things maybe for you from the industry that is well known. So sorry about. Yes, and of course you have other additives like the viscosity and tint adjustment agents, and of course it will include the filling of the final product into the container. If you, as you can see here, use solvents for cleaning all the containers and vessels, that VOC consumption from the cleaning agent for your equipment, you have to take into account for this activity too. And what you see, you are only under the scope of that activity if your solvent consumption, I will explain you what it is larger than 100 tons per year. That 100 tons per year here, in that case, it means the annual value. It is not the installed capacity, it is what you really do. So maybe in worst case, in 1 year, you can be under the scope, and maybe if, for example, have then only 90 tons in 1 year, so you will be out of the scope. But I can recommend to you, if you are near the threshold, it is very wise if you would plan and design your operations in such a way that you in any way can be in compliance with that requirement. So very important for the understanding of today for all of us is that we must differentiate between the chemical production of resins or polymers, and that what is the meaning in the chapter 5, this mixing and manufacturing of the paints. Please keep in note, for if you have chemical production steps in your installation, and it's a part of the, of course, of this paint manufacturing, because at the end you want to sell your paint. If I say paint, I mean really adhesives, I mean the inks for printing and so on. So please, for speaking, because it takes too much time, if I say paint, I mean all that codes and that materials that is covered in that VOC activity. So, but here we have to do a differentiation when we have chemical reactions in reactors as pre-steps for the production of the paints. If you have chemical productions, so if you produce your resin by, for example, by polyurethanes or epoxy materials by yourself, then please be aware that you will have an IPPC installation. For the chemical production, there is no threshold. It is only made on an industrial scale, but generally I would say that isn't the case. So if you have chemical reactions, they are not part of this VOC activities that is regulated in the chapter 5 and annex 7 and the part 2. Here I try to make it simple for you. So if you do chemical processing, then you have to look on the BAT conclusions for the manufacturing of this chemical production processes. If you have here the production of coatings and varnishes, then the installations, they will fall under the chapter 5. So if we look here on a typical case, you have here storage, for example, of monomers, and here you do the manufacturing of the polymers, and you see this I marked here with an asterisk because that part that is here in red, it is not, we don't have to consider for this chapter 5 installation. But for example, if you use the storage solvents, and that can be complicated because maybe for the chemical reaction you need solvents too, then you have to differentiate. You have exactly to differentiate what is the ratio that you use for the chemical process and what is the ratio that you use for just mixing, dilution, and so on to make the paints applicable. For example, if you do then water-based industrial coating, you know, water-based, that's especially important for those who are not so familiar. Water-based doesn't mean there's zero VOC. I mean, all water-based materials include normally some certain percentage of VOC. Sometimes they are not so less that percentages. So finally, you have to check on all that manufacturing steps where you have put solvents, VOC, here for the coating manufacture. So as I told you, first thing is always you have to check if you have such an activity. Here, if it's not, then you can be happy. So you are not under the scope, but let me say we have the manufacturing of such coatings, then we have to deal with the solvent consumption. And if we exceed the threshold here, 100 tons per year, then we have to look what we have to do. So here are some important issues I want to stress, because that's really important for the paint manufacturing here in Serbia. The so-called CMR substances. Here, the most important thing is you must substitute it. So that would be a good thing for even your applicants of the materials. For example, if you produce industrial coatings, your customer will be very happy if you already substitute the CMRs. But if it's not possible, the substitution, then you have to comply with, first you have to work in a contained way. And if for the stacks, you have this 2 milligrams as mass concentration for all CMRs in the stack. Similar is with volatile halogenated VOCs. Here I want to tell you, please take care, look on the Serbian class 1 substances. For example, I looked in that Serbian list and I found, for example, toluene, that is very common in paints, or methylene chloride, or xylene, etc. They are all listed as class 1 in the Serbian list. That means if you use toluene in your printing paints, for example, take care. When you do the production, you may not exceed in this stack gases this 20 milligram. And that is now very important. You will see for the paint manufacturing, we have something that is called a total emission limit value. I would say everybody in Europe is using that total limit value, but keep in mind, if you have materials like toluene and so on that are under that specific regulations, that specific regulations have priority compared to the total emission limit value. In other words, you have to comply with the total emission limit value, plus you must then take care for compliance with the stack emissions for this Serbian class 1 substances. I hope that is really an important message. I hope I could make it understandable for you. I think we can skip this. There are a lot of organic CMR substances. The problem is this list is changing very often. And for example, very prominent materials are this N-methylpyrrolidone. So that is very common in industrial coatings. So if you produce such industrial coatings, for example, for the winding wire, please be aware that first you have to substitute it. If it's not possible for you to substitute it, then you have to comply to this 2 milligrams for your waste gases in the stack. Additionally, you must work in a contained way. So there are a lot of common CMRs. I think I told you already the most important thing. Here, I tried to summarize the most important issues. So if you have identified now your VOC activity, you have to look then on the specific requirements, and then we will come to the relevant individual requirements for the activity. And additionally, maybe you have to take care about the monitoring, because how do you want to control the CMR emissions in the waste gas or Serbian class 1 materials? Of course, you have to do a monitoring, and this monitoring in the stack gases is one thing, but it includes the annual solvent mass balance, where I will explain you more the details. So now it's clear. Now we look to the specific requirements for the manufacturing of paints. Here you see the total emission limit value. And now you want me to ask me maybe how we can check the compliance. You can do it by using the solvent mass balance. That means you must determine the total annual emissions, and so you can compare it. So here you see now the requirements. Now maybe you're wondering, because I spoke about this total limit value, and here you see specific values for the stack emissions and for the fugitive emissions. So, but please look, first we have 2 thresholds. So the first threshold, 100 tons and 1,000 tons. And if you look now to the fugitive emissions, that is referred on the percentage of solvent input. And you see here it's written the same. So everybody is asking if I can decide if I want to be in compliance with this packet of stack emissions plus fugitive emissions, or if I have only to comply with total emissions. I think it's somehow logical, and nobody else could convince me in another way that all, as I know, decide on the total emission limit value, because it's the same value for the fugitive emission. It's the same here for the total limit. So everybody is applying to that total limit value. And until now, nobody could explain me what's the background to make it like this, because in practice, nobody is applying to that combination. Important for you. And that's good, because if you think what is the reason for that VOC requirements, we want to prevent and we want to reduce the VOC emissions. So we are not dealing with materials that are, or will not take into account, for example, for the fugitives, where the solvents that are in closed containers that you sell to your customer, because that are, yes, closed in a closed container. So as you can see here in a footnote, it's written that the fugitive emission value does not include that VOC solvents that are sold in the sealed containers to your customers. So maybe you see it here more clear. You have two alternatives. So you can decide for waste gas and fugitive emissions, but I cannot see any advantage for that way. So as I told you, all operators do a decision for the total limit value as it's written here. You see, it is a percentage. What you can learn is that it's an annual value, as is, so that it's clear that limit value will change every year, because it's always depending from your solvent input. And now, what is the solvent input? The solvent input is the total of what you buy in a year for solvent, and what you maybe recover and reuse for the same activities. That means for the activity manufacturing of paints. So from that total, that percentage, it means 5 or 3%, that is depending on the solvent consumption tons, is then the limit value where you have to show the compliance by setting up the solvent mass balance. What you can see, if you are maybe at this threshold, it is smart to reduce as much as possible the solvent consumption, because then it is an advantage by using the less strict limit value for the total emissions or for the fugitive emissions. There is a possibility to use a reduction scheme. I want to say it's not. Here, the reduction scheme makes no sense, because you have a total emission limit value that is something like equivalent to a reduction scheme, because that total limit value gives you all possibilities, whatever you like, what is useful for you, that you can implement. You can start to reduce the VOC content in your paints, but you can install a waste gas abatement, whatever it is. The ways how you solve the compliance problem is up to you. Important is that total emission value includes the fugitive emissions and all emissions in the waste gases. That means, for example, if you have a waste gas abatement, you have a cleaned waste gas, then you have to determine, of course, that value of quantity that will be emitted to the atmosphere after the cleaning. Yes, and very important, that's the reason I tell it now the second time. This total emission limit value is an annual value, and it is floating. It is floating because it is dependent on the percentage of the total solvent input that you have. Now here's an example. So you put in, you do the manufacturing now by mixing, not chemical reaction, but you do the paints by yourself. You buy maybe polymers and solids, and maybe these polymers, of course, they can have solvent content. Then you must know this and you must take this into account. So, for example, you have 1,000 tons here solvent input for the mixing process, and you have solvent in your product, 900 tons. So remember, in that solvent in the product, that is what you want to sell. So you pack it in closed container. It's not open, so it's not a fugitive emission. It is not any emission at all. So we speak about now from losses here of 100 tons, right? That means now you must look on the distribution. Maybe you have VOC in your waste because of the cleaning activities. You have used solvent and you collect used solvents and you give it for disposal to a specialist company, and you know that in the waste is 50 tons, but that is contained and closed, so it is not any emission. So that's the reason I did here a frame. What are really emissions? You see that are 45 tons fugitives maybe, because, and you have captured emissions, and it doesn't matter here if with or without waste gas abatement, it means you have 5 tons. So finally here you have then 50 tons, and that would be 5 tons of the input. That is maybe an example. So organic solvents. I think from time reason, it is clear. I don't want to go too much in detail, but I want to point out that that definition of what is an organic solvent is a very wide definition. It covers a wide range of agents. And so it's clear, first it must be organic substance and it must be volatile. So what is volatile? Volatile is if you exceed here a vapor pressure of 0.01 kilopascal at 20 degrees Celsius. But that's a crucial point. Here we have to look on the volatility, that means the vapor pressure, under the particular conditions of use. In other words, if we have some heating, maybe you do the mixing where you were thinking you're using a solvent that has a vapor pressure maybe at 20 degrees Celsius of less than 0.01 kilopascal, but during your mixing, it gets hot. You have maybe 50 or 60 degrees Celsius. You have to check if at that mixing temperature, that material maybe exceeds the 0.01 kilopascal. If that is the case, then you have to consider that solvent as a VOC solvent too. So solvent means not only solving the raw materials, but it includes cleaning agents, dissolvers, dispersion media, viscosity adjuster, surface tension adjuster, plasticizer, preservative, and so on. So it includes a big family of different types of agents. This is something that you, as when you do your paint manufacturing, must be aware that finally, I would say, you have to check all of your additives if they could be a volatile organic solvent. Here are some definitions. What is a coating and what is the ink and varnish? I think that is not now so important. There are some international standards on the definitions on paints and varnishes. I think that is something not so important. I want to point out again, I do it very often, I know. Here in the VOC directive, we have a different definition, and that's maybe very useful to know for you as paint manufacturer. That definition here is corresponding to vapor pressure. But very often, if you sell decorative paint, you will declare as a paint manufacturer a VOC content that is based on the definition on the Deco Paint directive. But keep in mind, that's a different directive. There, the VOC definition is based on the boiling point and not on the vapor pressure. So please, if you submit information to your customers, please take into account your customer. Maybe if they are working commercial or industrial, they need from you as paint manufacturer the information on the real solvent content. Let me say weight content, or you can declare it in gram per liter with the density, but they need exactly the VOC quantity of volatile organic compound based on the definition here of the chapter 5. Additionally, of course, you can inform the customer on the Deco Paint VOC content, but that please keep in mind that are not identical quantities. Sometimes they are very similar, but especially for water-based materials, it is not the same, because here that is a different laboratory analysis how you determine the VOC content based on the Deco Paint directive. So please, you as paint manufacturers, offer a service, and maybe you can change your safety data sheet, or you can make a special technical information, maybe submitted on request. But it is important that your customer will get the information about the quantity of VOC in your products, that exact as possible that you are selling. It is possible, of course, to calculate the VOC vapor pressures by using the Antoine formula and constant. So that is possible. So in the case you don't know exactly the vapor pressure at then maybe you can calculate it. But what we want finally produce are the paints, and very important again, we deal with the mixing. We are not dealing with chemical production of that binders or resins or additives. That activity deals only what you see here, mixing of the different components of a paint together to have at the end a paint that you can sell. I hope I made it clear now. So you have this binders that can be natural or synthetic resins, pigment that gives us this color, and then the solvent. Solvent can be a water too, but VOC also. In modern paints, you will have a lot of additives, because that additives do many things and have many effects. From the point of the application of VOC, Serbian VOC decree, we have to check if that additives can be VOCs. For example, if there are emulsifiers that are included in the definition of what is an organic solvent. And so you as a manufacturer have to check what you are putting in here, if those materials are VOCs under the definition, under the wide definition. Yes, so here you have the different materials. It's like cooking. And yes, so there are a lot of different type of paints. For example, if you produce powder paints, so they will probably not fall under the VOC decree, because here you have no organic solvents, or almost no organic solvents. To understand where we have the emissions, it's good if we follow the production process. So again, we have generally in focus the mixing and dispersion. That is done in what's called the dissolver. It's just a mixer. And that materials finally are mixed here together. So it's the same if you would do a cocktail. So you have different ingredients and you mix it together in your dispenser, that is in the dissolver, and that's a mixer where you have your nice ingredients, and later on you get your nice cocktail for drinking. Here you produce your paint or your glue or ink, what else. So, but after doing this thing, you have a milling process very often to make to grind all particles, that you finally get a very smooth and applicable paint, and then you can fill your produced paints in containers. Yeah, so it's the same here. Here at the end, you have this paint filling, and I've added here something because that is very important later for our VOC consumption. It's like if you cook, of course, after you're cooking, you know, somebody has to do the cleanup. Yeah, the problem is in my family, nobody likes to do this cleaning up, and probably it's the same in the companies. Because here probably you have to apply very often at least organic solvents for the cleaning, and of course that is an important VOC emission source that you must then include in your mass balance for the total organic emission value. Yes, so yes, this is only to get you, to show you that you get a feeling how it looks. So it's rather and very clean, as you can see here, the dispersion unit, the pigments and solids are added in a spatial addition unit here, and you see additionally there are always fixed tubes, so no there's no transportation by, let me say, barrels or organ or containers. So you have here tubes for the different main lines with organic solvents that you can connect depending on your recipe, and you have extractions lines, for example here, that are connected to the waste gas abatement. Here just I spoke about this mill. There are different type of mills. So for example, pepper mills and so on. Here you see the inside of such a mill, but that mills have the task to produce really very smooth and homogenized materials and paints to make a good paint. Yes, and at the end, of course, you have then the filling of tubes, and if you're using organic solvents at this filling lines, you will have always VOC emissions too. So normally you have to extract then the VOC from this filling. Here you see some smaller mixing vessels that are mobile. So in a paint manufacturing company, that mobile containers can be taken off, and then you see that is lowering down that mixer, and so you are very flexible in your work. But then after it is the work has done here, you have to close up that mobile vessels too, Otherwise, you will have a lot of VOC emissions to the room. Here you see some of that, yes, mixing vessels. For the smaller quantities, you see they have something like a flap where they can be closed. And maybe if you want to make it perfect, you can have here a seal in addition. So you have then a sealing in the if it's closed between that flap and the container. Yeah. So now the emission sources. What you see already here, that extraction lines. That means when you feed something in, you can extract that displaced waste gases, and here you have a central waste gas line where you can take it to, for example, a waste gas abatement. So what are typical situations? You can have a clean waste gas. For example, if you have a central waste gas line for VOCs during the filling of that containers and dispensers, then you connect it to a waste gas abatement system. That could be one possibility, or where you have what we call object extraction. You have such like a hut on one container or vessel, and you extract the waste gases and you put it to a stack. Here we have no waste gas abatement, so we have a differentiation, what we call O1-2. And you have here what is typically fugitive emissions are. You have openings by doors, by windows, and the room ventilation system, and so on. So that are not captured waste gases. So you can see that are what we call diffuse and fugitive emissions. Though typical sources are, of course, when we start from the production process, the storage tanks, for example, if they have no special breathing valves. And for the loading of that solvent tanks, you know, if they are empty and the road tanker is coming, then if you load this storage tank, that vapors would be displaced to the atmosphere. Here you can use, for example, the gas balancing techniques. When you work in a rather open way by, for example, filling mobile mixing tanks with solvents, there you will have VOC solvents. You can have VOC emissions when you do the mixing and dispersion, or because during that processes, the materials the mixture gets warmed up, and of course the vapor pressure will be increased, so you have a higher potential for VOC emissions. Yes, there are possibility, for example, of VOC sources during the decanting processes, like container to the mill, and then from the mill to the container. So everywhere where you do a manual handling, like in a kitchen, you know, if you take from the one container from the to the other one, and if VOC is inside, then during that decanting processes you have VOC emissions. Yes, there are some smaller sources of VOC emissions, but for example, if you fill your product into transport containers and the products contain VOCs, then again you have VOC emissions for sure. Yes, at the filling station, that when you fill your ready product into that small containers for selling, there you would have, of course, VOC emissions. You can smell it very often. So that are the main sources. So, for example, if you have such a system that is operated here, where you would fill in an open way by manually, of course, you will have here VOC emissions. But however, the goal of a manufacturing company is always to sell, not to lose the VOC, the solvent, because the solvent is very expensive. You're buying the solvent, and normally you want that the solvent is kept in your paint that you want to sell. So that's the idea. So it's your high own interest not to lose too much of the expensive solvents. When you do manual cleaning, and that is necessary because because it's like when you do your home cooking, at the end you have some containers that are dirty and you have to clean them. So you clean, for example, by the application of brushes. You have manual cleaning by racks and other things. So at the end, you will use probably solvents, and that can be a really high quantity. Here you see something like assessment of such a company. And you see what I told you already. You have emissions from the storage. You have emissions from the dosing and the pre-mixing, milling and dispersion, finishing and blending. And finally, you see at the filling, you can have some emissions. And the most part will stay here and remain in the finished product, because that is what you want to sell. And it's not normally the goal of the manufacturers to emit the VOCs to the atmosphere. It can't be the goal. Okay, now coming to the soil management plan. That is really the most important thing of today. You see that soil mass balance is a part of the soil management plan, because the soil management plan is more. The soil management plan is not an Excel sheet. It is not like only a chart of data. The soil management plan is something that is a full comprehensive approach. And of course, the mass balance is a very important part, because it shall demonstrate the compliance. But the management plan shall has additional tasks like the identification of future reduction options. It's like a management system that should help you as a manufacturer to identify, let me say, relevant VOC emission sources, and where you can take measures to improve your system. So, but now we want to speak about this mass balance with the target for the verification of the compliance of our emission limit. When you want to establish that management tool, or when you work out the first time that soil mass balance, it's useful if you organize a team. Not to do it alone, you need a team. It's important that you have a responsible person in that team. So then you go through the installation and you identify the VOC activities, the VOC sources, the relevant materials. That means you collect then the data on the materials. It means you have probably to get in contact with a lot of people in your company to get all the information. And then you have to do an analysis of all the data. You must check if you have maybe some information missing. You have then to ask your manufacturers. For example, in the case we heard before, when you sell when you buy resins from chemical installation, a chemical supplier, you must know already the solvent of that resin that you buy. So even if you only use that resin for mixing, but you get it in a organic solvent, you have to be aware on that quantity of organic solvents where you get this resin. So maybe you have to ask that supplier. And very important, that supplier should give you really that number in a very high precision, and not maybe to say it is between 10 and 40%. That is not accurate enough. So you must check the situation for the activity, and then you can start in the elaboration of a solvent mass balance. After you have done this, maybe you are happy and you see that you are in compliance. And if this match with your impression from the technical view of the installation, so everything is tight, you have no smells, or you see that it all is contained, then maybe the calculation convinces you with your personal technical impression. So, but maybe you are not in compliance, and you have to elaborate an action plan to achieve that compliance. And so you have, of course, to check if all the measures are taken, if you are in line with the timing and the deadlines, and you have to report the progress to the competent authority. Here you see what we call now the solvent mass balance. So don't worry, it looks only in the first beginning complicated, and especially for those installations like the paint manufacturing, who can apply to a total limit value. It can be simplified in almost all cases. So important for you is here what you put in is solvents. And we speak only on organic VOC solvents. That's the reason it's important to understand the volatility criteria and so on. So what you purchase and you've put in a 1 year period, that means from the 1st January to the end of the year, 31st of December, that you have to determine. And the same if you have a recovery, like for example distillation, and you reuse that recovered VOC, you must determine that quantity every time when you reuse it. It is very important, especially for you as paint manufacturer, because that, you remember, total emission limit value is a percentage, 3 or 5% from the total solvent input. And the total solvent input is the total of both quantities here. That means for each, let me say, recipe of paint that you are producing, you must install exact determination how much solvent you're using for each of the recipes. So it is something like in your management system. But it's something worthwhile because it will help you saving solvents. Some companies, they are not able to tell, for example, how much solvents they're using exactly for the manufacturing of a certain paint. I would say maybe yellow or something. Then that's not good because you must know how much solvent you are using for your VOC balance, but of course your customer must know exactly how much solvent you have put in. So it is a double benefit. If you know exactly how much you control this, what you put in for each of the paint type you produce, that will help you for your solvent mass balance. And your customer will be happy because you can tell him exactly, for example, we use 40% of alcohol, or I don't know what. So your customer will need this information for sure. So that is what you put in. Maybe you have recycled and stored solvent with besides this 12 months period, then that you can consider as 08. Or if you have recycled on site and you use it for another activity, for example, if you have a line where you are cleaning containers from that you get back from your customers. So that is then a line for the cleaning of these barrels or IBCs. But that and you use that recovered solvent from your production manufacturing line, then it is 08. So if you operate a distillation, for example, on your site. Then, for example, we have here this fugitive emissions that you see here colored in yellow. Here, for example, if it's not captured, then of course it is somehow fugitive. Here we have waste gases, that is where you have an oxidizer, thermal oxidizer, then you destroy that quantities of solvents, and of course that quantities are not under fugitive emissions. And then you have a captured treated exhaust gas, of course that is not fugitive too. Not fugitive too is if you collect all the VOC containing waste in closed containers and you submit it to as a disposer, then yes, then this is not fugitive and it's under the term 06. Most important is 07, because why? Because 07 is that quantity what you on VOCs that you sell, that is in your product. And remember, later when we do the balance, you are allowed to subtract this here. So if we look now on that figure, what is important for the paint manufacturing? It is that one, because that is a large quantity. And so you must determine that large quantity as precise as possible. Really, that is crucial. I can bray it, but like a brayer here, that is the most important quantity. The second important quantity is exactly the determination of 07. I know maybe some of you are already doing it, because you have an automatic system for the production line, but maybe some are not doing, and some have cannot tell exactly how much solvent maybe remains or is here in each paint recipe, and that will cause maybe problems. Here, it is absolutely necessary that you establish a system where you are aware on the exact amount. I mean, not exact on the last, what is exact? I want to say exact is that if you have not a range between maybe 10 to 20%, yes, as you can see sometimes in safety data sheets. No, you should be exactly aware on, I would say, in a range of a few percent, how much is here a VOC. The next important quantity, if you have a thermal oxidizer as a voice gas abatement, then it's necessary that you know exactly this quantity, because that will be very large too. That quantity is 0.6 and that 0.11 you will see for the total emission limit value, it will not be important. But if you remember, I told before, I spoke before about the CMRs and class 1 substances or halogenated solvents. That one can be important because here you have, or here you have to measure that critical and hazardous substances. So you have not only, in case you apply such hazardous solvents, you have not only to look on the total emission limit value, then you have to check the stack emissions, and you have to check the compliance with this general requirements on CMR, on class 1 substances or halogenated pollutants. Yes, so the solvent consumption, that is important quantity, and you can see the solvent consumption is calculated by what you buy in that year period minus 0.8. 0.8 is what I showed you here before, where you have on your site a distillation unit, for example, where you do this recycling from the process, and then you are not using it in the same time period, but you store it or you use it for another activity instead of that manufacturing of paints, maybe the cleaning of products. Yes, that I already have told you, and I think you're now aware that organic solvent is a very wide term where you have to take care, and you have to take care on that vapor pressure, especially under the particular conditions of use. So if you have mixing, normally you the coating mixture get warm, and you have then not only 20 degrees Celsius, and so you have to check if you have solvents, maybe where the vapor pressure then is exceeded. Important is too, if we have, for example, 2 activities, the cleaning of products and the manufacturing of paints. For each activity, you must determine the solvent consumption. And you can do this by a table here, where you must exactly determine what you put in, and you can calculate it by, for example, if you know only the volumes, you can calculate it then by the density, and at the end you can calculate it. So here's an example. You start your inventory, and you know at the end the different materials, and then you can calculate here the solvent input. Here's an example from a paint manufacturing installation. You see typical for some printing installation. You have here diethylketon and other typical solvent. You see exactly what I told you, and here you see important is the weight. Yes, that's the most important thing. Finally, you need to determine the weight, and you see then you can calculate the total solvent what you have used. Here we have no recovery. That means, if you remember, what is the solvent consumption? It is I1 minus 0.8. So here we have just I1. So it is because the threshold is 100 tons per year. So it is here exceeding, and that installation now is under the scope of the Serbian VOC decree. So what you learn, you must really do something like an inventory for the solvents, for each type, for each quantity, and you have to assess always your warehouse and the stocks at the end and at the beginning, and then what you have bought. Yes, you can calculate it by the density. So here's something like a recipe, how you can proceed. First, you must have something like a register. So normally you should have something like an inventory, because you know your recipes, and so you must have the best maybe on an electronic supported system. Then you must check all the VOC contents of materials that you put in. This is what I told you. When you get resins or other materials, you have to check the VOC content. You cannot say, oh, that's my resin A, and you assume that there are no VOCs, but when you are doing then the mixing process. So please check the VOC content of all materials that you're using for your paint manufacturing. And then you do such a list. And if you have solvent recovery unit and you reuse it, then for another activity, you can take this quantity 08 and you can subtract it from the solvent input I1. So that solvent input, as I told you already, is very important. I think I will skip this a little bit. If you need to calculate the concentrations coming out from the stack, here is a formula. Normally you measure it by a flame ionization detector. That means you have not the molecule, you get only the mass concentration if it would be total carbon. So you must convert it to the molecular weight. That's what you're doing with this factor Fs. And then you need exactly the calculation for your calculation, the average waste gas flow and the operation time. So you can only not calculate or doing your calculation as if you working in a continuous way. You must exactly calculate that quantities for only for that times where the emission take place. Yes, if you have a waste gas abatement based on destruction of the solvents, then you can use this formula, but it's important that you determine the efficiency of, for example, the thermal oxidizer, that you can do by a parallel measurement for the clean gas and the crude gas. Then you can get this efficiency, and you can calculate then the total quantity. Yes, coming now to the solvent, to the total emission value. Yes, you can calculate it here very easily. You, as I told you before, you have the fugitive emissions plus what gets out by stacks. And if you just using that formula, you will see, so it doesn't matter if you have 011 or 012, there's no differentiation necessary, because it will be, yes, eliminated. And at the end, you have only I1 minus 05 minus 06 minus here important 07 minus 08, because that are all That's the reason it's called indirect method, because we start from what we put in and subtract all that quantities that are not fugitive. So you see, that's the trick. Now you understand why I always say you must determine that quantities in a very high precision. If you have no incinerator, that means you have no abatement techniques that destroys VOCs, like, for example, a bioscrubber would destroy VOC probably too. So 0.5 then would be 0. So for all others where you have no destruction, 0.5 is 0. 0.6 is the waste that you send or submit to a specific company who can dispose this waste in a correct way. And now that is this 0.7 that you are allowed to subtract, of course, from the solvent input, because it is not emitted, it is what you sell in your paints. So at the end, if we assess what is relevant for the paint manufacturing, you see that formula will get rather easy. So here, that's the reason I summarized it here. You have, from my point, only two quantities where you have to really look with very serious. It's what you put in and what gets out in your paints. And if you want now to calculate the total emission limit, you need then this total input. It's I1, and that what you recover and have been used in the same activity, as it means in the paint manufacturing. You multiply it with a percentage, 5 or 3%, and then you can compare that total emission limit value with the real total emissions from your installations. So here's like a recipe how to proceed. Let's do an example. We have a solvent consumption of 8,000 tons per year. And we have a waste gas abatement system, a thermal oxidizer. We have automatic closed tank washing and so on. And if you look, that are the total input. Here, that is calculated or measured VOC emissions after the RTO. And because the operator is a very careful operator, he wants to know what gets out from the room extraction. So he did measurement at the room extractions where he calculated this. But I can tell you it's not necessary because we use the indirect method. And so it is not relevant. But here, it's important, we have to determine this destroyed VOC by the RTO. I have shown you how. We need the destruction efficiency. We do this by a parallel measurement between clean and crude gas from the RTO. We get the information, for example, how much VOC is in the waste by the specialist company, maybe by spot analysis, how much of the VOC is as an average in this disposed waste. And what we have to know, and you see why, again, you see this high number and this high number, that are the most important numbers. So here you must establish a management system to determine exactly the quantity of VOCs in your products that you sell. So if you know this and you use now this method, you can calculate the total emissions, and you can calculate it, that percentage, and you can see here we comply with the percentage of 3% from here, this total input. What you see here, it's in how can I say, summarized way, but you can understand again, the most complex is the determination of 07. That's the reason I repeat it so often now. And that one is not so complicated for the determination. Here, it's not a big quantity. You can do assumption or analysis. But that quantity I1, you see, that must be determined in a very accurate way, because that is the highest quantity of all VOC flows. Here's another example, but it's very similar. You need, of course, the hours of operation. We have here waste gas volume, the average concentration, and so on. So you can calculate the mass flow here coming out from a stack. And so when we want to calculate the room ventilation, because the operator is interested in, so he can use it hereby if you know the flow and you need the average concentration that was measured, and you can use a response factor together with a factor for getting the molecular weight. Here is this 1.3 as a factor. So you can calculate the total emissions, fugitives, and from the stacks. Then you can do a compliance assessment. You see, if you do compliance with the total emissions of 3%, you see here it is complied with, but this emission limit value of 150 milligram is exceeded in that case, where we have, but the operator can be happy because he can choose the total emission limit value. And that's the reason I have shown you here this example. So this 150 milligram is not relevant for him, because he will tell you as an authority, I want to comply only with the total emission limit value, and that's possible for him, so he can do this. Here is another example. So again, you need the input of the solvent. Then you do the solvent mass balance. You know the captured waste gas emission, because you can easily measure it, and you know normally the solvent in waste. And what you should know is what you sell. Then if you do the calculation for that small installation, you will see here the compliance is given. So 5% is the limit, and because of the solvent input. And you see that installation has only 2.7%. So to tell you the truth, what I'm showing you now, what is called best available techniques, maybe, how can I say, in some cases it's overdressed and is not maybe the reality for many operators. But maybe that pictures or that topics can show you what can be the way to improve the installations. Of course, I have chosen examples now that are on a very high level. That's the reason it's called best available techniques. I know and I'm aware that even in Bavaria or in Germany, we have smaller installations where that equipment is not applied. Let me say this high-end or high-level equipment, because in the paint manufacturing, it's like in a kitchen. Many things are done manually, especially if it's produced in not such quantities. So I only want just to add before we start here, because if you see here, that, for example, is a very high-end level installation where you see everything is closed. It has, for example, if you put something here in, the solids are extracted to a solid waste gas line. You see all the lines in the background. That means all that lines are coming from solvents and resins. So nothing is done manually. And in some cases, you can use flexible tubes. So you have a high flexibility. In other words, that installation is done in a very closed and automatic way of production. And that, I think, is the trick. As much as you can avoid doing manually, as less fugitive emissions you will have. In other words, if you have closed tubes with solvents that where you fill your mixers and dispensers and so on, then you have no, manually handling processes, and you have no VOC losses. So what is the rule? First, try to prevent emissions by using closed mixing containers as far as you can. There are mobile apparatus available on the market, as I have shown you before, where you can just drive with your mobile container, and then this apparatus is lowering, and when you do the mixing, you have a closed container. And after the mixing, you can put a foil on it, or you put a cover with an appropriate seal on it. So you have only a short time where you have VOC emissions. If you have a larger production or larger units, try to make it really in a closed system. So if you have non-closed systems, so that is what I said already, use leads, use sealed leads, use foils or similar covers and don't leave them open in the working room so that you avoid fugitive emissions. When you work with high VOC content, it could be useful if you capture all of the concentrated waste gases with VOC and you feed them to a waste gas abatement unit. There can be different waste gas abatement applicable. So that is maybe the recipe I can give you. Yes, if you here want to apply to an appropriate waste gas abatement, you have to maybe take into account additional things. First, it is important that you have targeted extraction. That means not an extraction of the whole working room volume, because it is not possible, because of the volume is too large to use such a waste gas abatement system. Important is that you really do a efficient extraction from that containers, or you apply extraction hoods to wherever it's possible, where you extract the VOC gases to that abatement unit. Important is to keep the waste gas volume as small as possible. So you should implement or install in the line something like a valve. The best would be automatically, but manually it's okay too. A valve in the extraction line where you close that line when you don't use that lines. In other words, when you have no fillings or you have no containers connected to that waste gas extraction line, it makes no sense if you extract air volumes from the working hall to that waste gas abatement. So the idea is keep that extracted waste gas volume as small as possible. Additionally, there, as I told you, even if you apply waste gas abatement unit, make preventive measures, for example, gas balancing. You will see in some pictures then in some minutes, when you receive your solvent to your storage tanks by a road tanker, just use and apply a waste gas balancing line. So the displaced waste gases during the loading of the container are taken back to that container where that unloading takes place. Try, in other words, to establish a closed system as far as is possible. So very often you have filling processes. Here it's the same. When you start filling processes from the main storage tank, from the bulk storage tank to smaller containers, you can do the same using a gas balance line. And use wherever it's possible, not open mobile container. Try to put a cover on it. Important, try to reduce the temperature by using, for example, cooled vessels when you do the mixing. If you as much or as high as the temperature of the liquid, of course the vapor pressure will increase and you will have higher VOC emissions during the mixing processes. And don't use long transport distances. Try to make the transport distances very small of the mobile containers, and so try to establish a just-in-time production so that you don't keep, for example, what I have seen very often, mobile containers standing in a row over some time. Try to just work in just-in-time and don't store that mobile containers. Yes, very important is the good housekeeping. By that good housekeeping includes, for example, that you use technical tight pumps, for example, magnetic driven pumps, and to use so-called high-end materials like flanges, valves, and especially modern closed container washing systems. You will see in some minutes there are available on the market low VOC cleaning agents. So I want to come back to the definition. What is a VOC? Remember, it doesn't mean that you can use an organic cleaning agent. It should not be volatile. That's all. So in other words, if you are when you are using a organic cleaner, that's okay, as long it is not under the criteria volatile. There are modern agents, very often based on water or alkali, or there are agents that are organic but not VOC, so that you can use, for example, for washing of the parts and the equipment. If you are operating, I would say, in a larger scale, you can think about to install pick systems. If you have to change products, and you have to clean your pipes, so you can use that picks to reduce the solvent consumption for cleaning. So here, as you can see, that is this closed mixing system. And if you put in solids, you have an extraction line that feeds the extracted dust containing air to a fabric filter. Here you see, yes, a very closed system too, with extraction lines to a waste gas line. And here you see a condenser for the solvents. So you have maybe a heat, and you have some some VOCs and solvent from the solvents. So you do here condensation, so you can reuse the solvent that can get back here in this manufacturing process. Yes. I skip a little bit the things here because you will get it anyway. But the core problem in the paint manufacturing are the application of not closed system. I mean, that is exactly where the VOC can be emitted, fugitive, but of course there are VOC emissions. So the reason is, when you do your solvent mass balance, I showed you this plan, do and act, and so circle process. This solvent mass balance will help you to identify your losses and will identify your problems. In other words, it can help you for sure to improve your process. So if you do that solvent mass balance together with something what I would call solvent management plan, because plan means the word you plan something to do. That means you want to improve your processes. And by improving the processes, you will save your resources and you will save your solvent. That means you save costs. So try to make to analyze the working steps. For example, you take one recipe where you see there is a lot of things is manually done. And then you analyze that process and you think, what can we improve? Maybe then you can maybe reduce, for example, the solvent content in your coating. That would be very good for all. But maybe you think, oh, for us it's not makes no sense. We cannot do this. But what you can do, maybe, for example, to improve the extraction of the VOC waste gases, and then you can connect it to a waste gas abatement system. So you will see. You will, if you do the first time that solvent mass balance, and together when you start, as I have shown you, and you analyze, you go to each station, to the processes, to the recipes, and you will analyze your process, and you will see where is your situation. And if you see that you have no compliance, and no compliance is in view, and then you have to think, for example, and you want to keep on using VOCs for the production of coatings, then you probably have to install a waste gas abatement system. And then you must think about how can we extract that waste gases so efficient as possible, and that we don't have too much waste gas volume. So when you decide then on a waste gas abatement system, you can think about on incineration techniques, but you maybe, if you have some only one solvent, if you produce a specific printing ink, you can think maybe use a biologic waste gas cleaning. And of course, you can think about recovery and together in with adsorption technique. So active carbon filter or zeolite material. Here's an example of, but for very common, you will see so-called RTOs. It's nothing else than an incineration, a thermal oxidizer, where the VOCs are oxidized to CO2 and water. So a first step can be the application of a condenser, where you try to that the VOCs will not escape here to the atmosphere, but you try to get out as much of VOC gases and you make them liquid again. So you can use this condensate here again for your production process. There, for example, for filling, you can, if you have such a filling nozzle, you can use it with a closed loop flushing line. That's important if you have a lot of changes, of course, of products when you fill, and you want to not to be that the products are contaminated. So you can apply a closed flushing loop for that filling of the products. Or here is something very simple, just to use a cover with a flexible film. Here is again something where you try to make it close. You have here this pipe tongue supply lines. You see it's electronically metered, and all is done in fixed lines, so not manually. Here you have your mixer, and you have something here where you can extract the gases. And the good thing is there's something like an interlock, so that extraction line is only operated if this process is running, and not if, for example, if it's in an idling situation. Here you see this flap inside the channel. So this gases will be only, or this extraction is only open to the waste gas abatement if really operation takes place. Otherwise, it is closed. Here are some pictures of manufacturers of such mixing units. Yeah, you see again here this extraction line, this condensator. You see this addition of solids. Everything is very closed and clean. So that's a filling line. For if you work with VOC, for example, you can extract the waste gases when you fill here the small containers or bottles. You extract the VOC, and you can take that VOC gases to the central waste gas abatement, for example. So here you see a filling line too, full automatic, and it works all the time. And you see we have an extraction line then, where it is then the VOC gases are cleaned by our waste gas abatement together with all the other VOC gases. Yeah, that are all examples of very closed and manufacturing units. you see you have not much losses. There's a good housekeeping, but I told you that are special cases. So, and I can I could show you other pictures too, where you would get another impression. You see here again the extraction lines. Here, that is now at the end of my presentation. I want to point out the relevance of cleaning of parts and the cleaning of mixing units. It is like in your own household. If you manufacture something or if you cook something, you have some rests, and then you must clean it. And during that cleaning stages, of course, you will have emissions. Very often, that cleaning procedures are done manually. That means by people. But nowadays, you can find automatic closed systems. Even that VOCs are applied, or VOC containing solvents are applied for that cleaning purposes, but everything is closed and sealed. You have not much emissions. Here, for example, you have an extraction line where the VOC emissions will be extracted then to the central waste gas unit. So here you see in different sizes and different possibilities to work in closed washing machines. So the good practice would be, yes, to take care on the good housekeeping, and very important is this training of your workers. That means if the workers are aware that about to work very carefully, and for example, if there are splashes and spills, to clean it. I mean, I can tell you, in one of such a company, I did an inspection, and during my inspection, there were two people a filling or unloading process of a solvent. So they had a IBC container, and they were pumping by a membrane pump some alcohol to another mixing vessel. And when I saw it, I wondered because it is, if if I use a tube for and I have a pump for my garden, if it's hot in summer times, and if there is a hole in the tube, of course I have something like a spring. And the two workers, they had such a hole in the tube, and there was a spring maybe 40 centimeter high. And what they did, they were very smart. They put a small container, so they collected the liquid that came out by this hole of the tube. And yes, and I asked them, if they are thinking about the VOC and fugitive emissions. And they answered to me, yes, they like the smell of the VOC. So that can be a problem in the practice. Some people like the smell, and so they don't care so much. But it is really important to improve the awareness on the hazardous risks on VOC, because we spoke now on the environment, but please don't forget, most VOC are flammable. So we have not only a risk for the environment, you will have always a risk on plant safety. So you don't want any explosion or that something is burning. So the awareness is really crucial. Yes, that means it is important to keep the floors and the machines clean. So cleaning operations are a very important part of the solvent management plan. This good housekeeping, even the same for VOC containing waste. So that material should not be kept open. It should be closed in special containers for VOC containing waste. Finally, you need something like working instructions and of course a training of the workers. Important is that you can convince the worker. That I think that's very crucial too, because if you have somebody who likes that smell, it's maybe hard to convince him to work in a very tight and clean way. Yes, for the storage, I can recommend to you use this gas balancing lines and use over and under valve pressure valve to reduce the VOC losses by breathing, by the temperature fluctuations. And the gas balancing is really, I would say here in Germany, and not only in Germany, it is something state of the art. It is very common to do this. Yes, if you want to do more, you can use this technical tied pumps, and maybe even for if you have IBCs, I have put this figure here for you. You can even with IBCs, you can simply apply this gas balancing line. That means if you, if you fill solvents in your mixing container from a IBC, you can, for example, just feed back the displaced gases to the IBC. Or if you have not the possibility, maybe you can use to discharge it to an adsorption canister or other waste gas abatement line. Here you see that gas balancing, even that's possible for smaller barrels. You see, you fill something in a solvent. You see the label here. And if you apply such a double wall loading device, that tube feeds back then that displaced VOC containing gases to, for example, to the solvent container. So, for example, you see on the picture, the company Elaflex in Hamburg is offering such systems, but there are a lot of other who are offering. You can use spatial containers. You can see here. It's a spatial waste VOC, a liquid VOC waste container. So you see everything is closed here. You have spatial connectors. So one is for the filling and one is for the gas balancing. And you have a closed system. That is something more for larger installation, when that you can use something like a pick. You see a pick, it's not a real pick, what you eat. It is a cleaning tool where you have this plastic part that you shoot in that line and that does the cleaning. And so you can do very easily changing of colors and solvents. You're using stirrers for the mixing. Here, for example, that's a stirrer had a double seal to avoid losses of VOC if, for example, one seal would be broken or defect. So gases could get out here to the room. If you use this double seal and you have a control of that medium inside, then you can be on the safe side. Or you use a double magnetic driven pump or magnetic driven stirrer. That's possible too. Here you see technical type pump like a membrane. You see this membrane is just up and down. You see there is no, there cannot be any leakages, only if the membrane will be defect. But normally you have no VOC vapors that will get out here. Yes, it's the inside of double sealed, for example, stirrer. You see that is where you have this control medium. So you can, if there's a failure in the seal, you can recognize it at once because you can measure the liquid level of that barrier media, or if you can measure the pressure and so on. There are different possibilities to check this. Here you see all are equipped with fixed lines and tubes. So no manual handling takes place. In Germany, I just want to end here. We have a requirement for permitting of the different type of production of coating installations. It depends on here, for example, from the tons per day. What you can see when we do that permitting, we do an assessment what the operator has established or installed as measures for VOC reduction. That means nobody may operate such an installation before he has received the environmental permit. And in the environmental permit, we deal with a lot of things. For example, the stack height. We check if there can be order problems. So we do really a deep permitting assessment. And finally, the operator will get a permit with all permitting conditions. So this is something what we do for that type of installations. I just only wanted to tell you, to show you how is the situation in Germany. In Germany, in our ordinance, we have some stricter regulations and emission limit values as you have with the Serbian VOC decree that is based on the European level, let me say like that. My request to you as manufacturers who are here today, try to reduce your VOC content in your paints. Why? Because you have downstream users, and we are not dealing only with you as manufacturers. You are on the top, but you have downstream users, and if they use VOCs, they have a lot of work with the VOC decree. If the downstream users can apply waterborne or high solids or other coating materials with a lower VOC content, you will make their life much easier. So you as a coating producer play an important role in that whole story of solvents, because you put the solvents in the paints and the others are using your paints. So if you are able to reduce your VOC, that will help you because you have your own duties, and you would help all your downstream customers. And another thing, there is always a big confusion. I can tell you, because your customer are not able to do a differentiation between what is the VOC content, what they need, for example, the quantity for their solvent mass balance. Very often they use the VOC value from the DecoPaint directive that you as supplier or manufacturer declare in your safety data sheets. But the customer is not able to understand that what he's using is not the correct value, because both sounds very similar. So please, it would be a help if you if you publish your safety data sheet and that you do this clear differentiation, you declare it where applicable for the DecoPaint directive, and you do another VOC content that is based on the Serbian VOC decree. So that would help your customers. And very important, please check your recipes on hazardous substances. Again, it's the same story. You will help yourself because you have your own duties, but you will help all your customers, because now when the VOC decree will be implemented, your customers will ask you, because they don't elaborate or manufacture the coatings. They will come to you and they will ask you, can you send me a declaration that we have no CMR substances, or we don't have the Serbian class 1 substance in our coatings that we buy from you. So it is wise if you try to revise your recipes to prevent and avoid the input of hazardous substances. That is my clear recommendation to you as a manufacturer. So you see at the end, if we will be able to use low VOC coatings. So it is done then. If you manufacture low VOC coating, your customers will have low VOC emissions when they do the application of the coatings. And don't forget, it is not only for the environment. If you reduce the hazardous substances and if you reduce the VOCs, you will help in your installation to improve the occupational health, and of course you will improve the risk for on hazardous effects like explosions or other things that can take place. So if you reduce that VOC, it will have a positive effect on other issues like plant safety too, and maybe you can save then the money because you don't have such high demanding requirements, for example, fire protection and so on.